We're now going to create the double angle formulas. And basically we'll use the ones we saw the other day. The sine of 2 theta. We could rewrite 2 theta as theta plus theta and then use our sine cos cos sine. If it's a sine, it's a sine. But now we notice the two terms are actually the same terms. Therefore, it's just 2 sine theta cos theta. Cos 2 theta is a little bit more interesting though, because when we go cos cos sine sine, which creates cos squared minus sine squared, but we also have other identities that could change that. See, I could change the sine squared to 1 minus cos squared. And rewriting that, I get that it's 2 cos squared minus 1. If instead I substitute in for cos squared, so 1 minus sine squared, we could rewrite it, and there's a third way of doing it. Now let's create one for tan. The tan was tan plus tan on 1 minus tan tan. Top of the fraction will simplify because I can add those, and the bottom we can do something with as well, and there we get it. 2 tan theta on 1 minus tan squared theta. So there are our double angle results. Let's summarise those. There we go, sine 2 theta, 2 sine theta cos theta. Cos 2 theta, cos squared minus sine squared. We could rewrite that as 2 cos squared minus 1. But this is really useful, certainly for later on when we look at the integration of trig functions. If I make cos squared the subject, I've got a way of rewriting cos squared in terms of the double angle. So I could say that's a half of 1 plus cos 2 theta, and we get a very similar one with the sine squared. When I rearrange that one, I get sine squared as a half 1 minus cos 2 theta. So basically they're the same, but the cos squared is plus cos 2 theta and the sine squared is the minus cos 2 theta. And there's our tan 2 theta, 2 tan theta, 1 minus tan squared theta. Okay, we know cos theta is 2/3. They want us to find tan 2 theta. We can now create the tan theta as root 5 on 2, substitute that in, and playing around with it, there we go. After all that, we get minus 4 root 5. I want to find the exact value of sine 5 pi on 12, cos 5 pi on 12. So I see the sine cos, and I go, well, hang on a sec. Sine 5 pi on 12, cos 5 pi on 12? Well, that's just a half of 2 sine cos. And I know 2 sine cos is sine double the angle. That would be 10 pi on 12, which is 5 pi on 6. We've got an exact value for 5 pi on 6. I can substitute that in and we get a quarter. Well, actually I want to find half of the angle rather than double the angle this time. Well, again, this is where the rearrangement of the cos 2 theta one can become useful. Because the sine squared theta allows me to rewrite it in terms of double the angle. Well, I want to find sine of theta on 2, double of that is theta, so I could use this formula. Sine squared theta is a half of 1 minus cos 2 theta. Well, that basically means the sine squared of a half theta is a half of 1 minus cos theta. They told me cos theta was 2/3. That's sine squared. Therefore, it's going to be plus or minus. Now, which one is it? I don't really know from the information they told me. So sine, it could be plus, it could be minus. Let's say the angle was 400 degrees. The cosine of 400 would be a positive number. Divide that by 2, I'd get the sine of 200, which would be in the third quadrant. That would be a negative number. So I don't know, is it going to be plus or minus? So the best I can do for this question is to go plus or minus, unless they give me more information. Well, let's prove this identity. Square root of 1 minus cos 2x on 1 plus cos 2x is the same as tan x. Okay, well, I'll substitute in for the cos 2x, but I'll do it smartly because I've got different ones I can use for cos 2x. So which ones will I use? I know where I want to end up. I want to end up with tan, and tan is sine on cos. It would make sense then that in the top I use the 1 minus 2 sine squared, but in the bottom I'll use the 2 cos squared minus 1, because that will create sine on cos. Let's now play around with those, and the top is 2 sine squared on 2 cos squareds. The 2's will cancel, and obviously the sine on cos is tan. The square root cancels with the squared, and we get our tan x that we're looking for. Let's look at this HSC question from a while back now. You had to prove this. A lot of people wasted time with it. And then they looked at sine 3 theta and said, oh, look, I could rewrite sine 3 theta as the sine of theta plus 2 theta, and then go sine cos, cos sine, then use double angles, and a lot of, I mean, it works, it takes a lot of time. What they should have done, and hopefully a lot of people did do, is treat it like an algebraic fraction. If you treat it like an algebraic fraction, look what you get. See the top of the fraction, sine, cos, cos, sine. We've got the pattern. Well, that's the sine of 3 theta minus theta, whereas on the bottom, sine theta cos theta, well, how about I make that 2 sine theta cos theta? I can't just change the question, of course. So I multiply the top of the fraction by 2 as well. Well, look what happens. The top of the fraction is now sine of 2 theta, but so is the bottom of the fraction, and so the answer is 2. A lot quicker than doing it the other way. Well, you first look at this and you think, look, it's just the tan of 2 theta result, but it's not. You look at the bottom of the fraction, it's 1 plus tan squared, not 1 minus tan squared. Something else is happening here. We've got to turn it into sine 2a. Okay, so how are we going to do that? I've obviously got to change the tan. I need to get sine in there. The best I could really do then is to make that sine on cos. Right, let's play around with that, see what happens. Want to get rid of those denominators, fractions on fractions, hate it. Multiply top and bottom by cos squared. Now we see something nice. The top of the fraction becomes 2 sine cos. We know what that is. The bottom of the fraction, we've got cos squared plus sine squared. We know what that is as well. So we have sine 2a on 1, which is sine 2a, and that's what they wanted. Sine of 2 inverse cos of 3/5, but remembering the inverse cos is actually an angle, so it really is saying the sine of 2 theta. All right, let's say theta is the inverse cos. I can draw myself up a little triangle, find the other side, and read off any ratio that I would like to read. That's going to be 2 sine theta cos theta. So I would like the sine ratio and the cosine ratio, and we get 24 and 25. The other way around, inverse cos of 2 cos pi on 3. Wow, fortunately they gave me a nice number. I can actually work out what the cos of pi on 3 is. So I get 2 times a half. It's really just asking me what's the inverse cos of 1. That's 0. Okay, that shall do it. 17e we'll play with.